Alright, today in video number 4 we're going to talk about a number of different CompTIA 902 software items, first of which is different types of networks. First one, smallest, is a PAN or personal area network. You might think about that as something at home, perhaps a couple of PCs, maybe Bluetooth printers, something of that nature. The next one up from that is a LAN or a local area network. That would be pretty much a stub network if we want to think about it in those kind of terms. Like the office that I work in here at my private employer, we have a local area network or a LAN. Everything sits behind a border router. The next one up from that would be a MAN or metropolitan area network. We have something like that in Lafayette where we have metropolitan Wi-Fi access throughout most of the city. That's available, no charge. And then the biggest one would be a WAN. The obvious example of that would be the internet, a wide area network, or a network of networks. Next we're going to look at IPv4, class A, B, and C, and their corresponding subnets. If you look on the slide here, we got class A, that is anything from 0000 to 127.255.255.255. Class B, and the default subnet for that is 8 bits or 255.0.0.0. Next class range is class B, that's 128 up through 191.255.255.255. Default subnet for that is 16 bits. And then the class C address, which is what most of us are probably familiar with working with, ranges from 192.0.0.0 up to 223.255.255.255. The subnet for that is 24 bits or 255.255.255.0. On the private IP addressing, class A private IP address network address range in there is the 10 network, so we've got anywhere from 10.0.0.0 up through 10.255.255.255, and the corresponding subnet mask for that. Class B, the private network address for that is 172.16.0.0 up through 172.31.255.255, and that is 12 bits or 255.240.0.0. Class C private IP address is 192.168.0.0 up through 192.168.255.255. Subnet mask for that is 16 bits or 255.255.0.0. Private versus public IP addresses. Alright, this is an example, and this is going to kind of tie in with our NAT discussion later on. Here we have an example of our private network. We've got a 192.168 network here behind the router, and then the router is using NAT to translate those into the public IP address of this network, which is 92.30.112.45. So this would be our public network address, and this is our private network addressing. APIPA. APIPA is automatically used by Windows to auto-configure an IP address for the host if it cannot reach a DHCP server to obtain a IP address lease. So anytime if we go into ipconfig and look at our IP address, if it starts with 169.254.anything, then we know we have a issue trying to contact our DHCP server. Static Addressing versus dynamic. Obviously DHCP, dynamic host. Static addressing is where we give the device on our network a permanent or static address. Those are normally reserved for items that are on a we have to always reach it basis. So obviously things like servers, printers, routers, switches, those types of things. Let's see, basic difference between IPv4 and IPv6. IPv4 is a 32-bit addressing convention. The problem that developed with that, there are 9 billion some odd addresses available with that. Well, we have run out of those for the most part. So IPv6 was developed. It has a 128-bit addressing convention, and there are some other differences there, but those are really the two major differences. IPv6 has umpteen gazillion available addresses that can be used on the internet. Right now these run concurrently, so that there's going to be a transition period where we transition from IPv4 over to IPv6. IP ports. I wanted to show this diagram because I think it's a really good example. Down here we've got layer 1, layer 2 stuff, layer 3 with our IP address, IP protocol, layer 4 with our transport layer, TCP or UDP, and then up here we've got our application layer where we might be using HTTP, FTP, RDP. If we're doing email, we might be using either SMTP or POP or IMAP. And the application layer and the transport layer actually uses ports. And so we're going to look at port assignments here. So up here, another good graph that I have, HTTP uses port addresses. TCP/IP uses IP addresses. Down here on our hardware layer, we're going to be using MAC addresses. So let's look at IP ports. FTP, file transfer protocol, that uses ports 20 and 21. Telnet's port 23, SMTP 25, DNS 53, HTTP 80, POP3, IMAP, HTTPS, and RDP. Different protocols and what they are, what they do. DHCP, dynamic host configuration, so that is set up in a client server environment where the client is going to contact the DHCP server and request a IP address lease. And so if that happens right, the host will get an IP address, subnet mask, and the default gateway. DNS or domain name service. DNS maintains a directory of domain names and the translation to the corresponding IP address. So rather than me having to type in 12.20.300.112, 300 is not valid, but I can type in yahoo.com, and my computer, through the wonderful world of DNS, makes that translation and makes that happen. LDAP, or Lightweight Directory Access Protocol, that is used. I see that a lot in schools, where a user can authenticate on the network, and then they are able to locate files or anything that they've got sufficient rights to reach. SNMP, Simple Network Management Protocol, that's used to get information from devices like servers, switches, routers on an IP network. SMB, or server message block. That's an application layer network protocol that we use mainly for file and printer sharing on the network. They recently released SMB 2 and 3, and that has wreaked havoc in the printer industry world because print drivers have been written to support SMB 1, and so the printer manufacturers are scurrying around getting driver files updated to be able to support SMB 3. CIFS, Common Internet File System, that is similar to SMB, but it also it extends it out through intranets and the internet, so it's an enhanced version of SMB. SSH, or Secure Shell, that is a secure alternative to Telnet, where we can have a secure access to a remote computer. SFTP, FTP is file transfers, so S would be a secure version of that. TCP/IP, that's Transmission Control Protocol, Internet Protocol. That's the TCP/IP stack or TCP/IP suite that is used for internet communication. Wireless encryption standards, we've got WEP, WPA, and WPA2. Here's a real brief overview of those. WEP is the original encryption standard, which used the static encryption key. Obvious problems with that, fairly easy to hack, and so that one's pretty much outdated. WPA, or Wi-Fi Protected Access, was designed to replace WEP. It's stronger than WEP because it uses a constantly changing set of encryption keys. WPA2 is an enhancement upon WPA because on top of that it also uses AES, or Advanced Encryption Standard, that improves the way that TKIP generates the keys in WPA. Alright, SOHO, small office, home office. While we're here on, on the wireless topic, though, let's go ahead and hit the WPS. Wi-Fi protected setup. We can, when we're configuring a wireless access router, we can enable WPS because it makes it easier for our users to connect, especially if we have difficult to type or remember SSIDs or passwords to the Wi-Fi network. However, one of the ways we can do that is to have a 8-digit PIN generated. Well, 8 digits is not going to take somebody long to crack that, so it can create an obvious security risk. So we as administrators want to turn off or disable the WPS when no one needs to connect to our Wi-Fi network. Let's see, I'm not sure what happened to my, there we go. Port forwarding, port triggering. This is my port triggering slide. MAC filtering. At my home I used to have a AT&T hotspot because we live out in the middle of nowhere. And one of the ways I helped secure my home network was to use MAC filtering. So after a device had connected to my hotspot, then I added that to my list of valid MAC addresses for the device to accept. And then I said, okay, these are the ones that I want. Deny any other MAC addresses. That's as good as it can be, short of MAC spoofing. Port forwarding, we use that, and my private employer uses that because we have a web-based application that ties into a internal database here. So when any of my field people pull up a web page and it directs them to our router, which redirects, the router is configured to say, okay, well, when requests come in for port number such and such, redirect that to this private IP address and port on host IP address such and such on our internal network. So that's how port forwarding works. Port triggering works a little differently. So here's a graph of port triggering. Let's say that we need to have whatever we're connecting with, it needs to be able to respond to the same port or a of the sending machine inside our network as the receiving device out on the internet someplace. And so port triggering is used to set that up. The problem with port triggering is if I've triggered a certain port on the router, nobody else can use it until my application releases it. SSID broadcast on and off, that's another method we can use to help secure our network to some extent. The broadcast, the SSID is still there, and we need to know what that is in order to validate to gain access to the wireless network, but we can turn off the broadcasting of that address. We've already talked about wireless encryption, firewalls and DMZs. Let me pull that up here. Firewall, it's a border device that examines every packet, whether it's, depending on how we've got our firewall configured, it might be outgoing packets, it might be incoming packets, it might be both. And it's going to examine that packet and decide whether to allow it in or out of the network. DMZ, or demilitarized zone, is a computer or could be a network that is not protected by our firewall. It's still part of our network, and it's an extension of our network, but it sits outside of our firewall. Let's see, NAT and PAT. NAT we looked at briefly a little bit earlier. Where's my NAT? Where's my NAT? Anyway, network address translation. While I'm looking for that slide, network address translation. Here we go. As I said earlier, that's going to translate private to public and public to back to private. The main difference between NAT and PAT is PAT uses a it's not a one-to-one linkage like NAT is. NAT would have, this machine would be linked to one IP address here. This machine would be linked to another IP address. With PAT, it's more like a floating pool. So they're going to share IP addresses in there. WPS we already talked about, and let's find quality of service. Here's a screenshot of a router. So quality of service, basically we're making decisions as administrators as to which type of traffic on our network deserves higher priority so that we get a better quality of service. So this is a screenshot here, might be kind of hard to read, but we've got some different applications down here. We've got Skype, we got Instant Messenger, we've got Secure Shell and iPhone, some other things in here. And so in our router configuration here, we can go through, we can highlight one, and then we can change the priority here, highest, high, so on and so forth. So we can help decide how help the router decide how to balance a limited amount of bandwidth that it has available. iOS interfaces. The main difference between Android and iPhone, they're becoming very, very, very similar anymore, and actually there's very little difference between the interfaces. The layouts inside the applications look very similar: texting, emailing, all those sorts of things. One of the main differences that sticks out in my mind with the Android phone is that you get the back and forth little arrows down at the bottom of the screen. Processors on mobile devices. iPhone 6 that uses a A9 processor that's actually made by Samsung, who's the biggest Android manufacturer. That's got a 1.8 gigahertz dual core, and Apple also uses that in the iPad. Over on the Android side, looking at a Samsung Galaxy S8 that uses a Samsung or a Qualcomm processor, which is a 2.3 gigahertz quad core. So if you're looking at comparing a 2.3 gigahertz quad core against a 1.85 gigahertz dual core, all other things being equal, the Samsung is going to process faster. Rooting and jailbreaking. Those are a couple of terms that we talk about with smartphones. Jailbreaking is associated with Apple devices, and so to accomplish a jailbreak, a custom kernel is used to grant root access to the device. The only advantage to jailbreaking your phone is that you can download apps that are not in the Apple Store. You can use other themes and extensions that Apple doesn't support. But you do still have all the regular functionality of the iPhone. You still got access to iTunes, the App Store. Jailbreaking, however, on the Android side is completely different. Rooting on the Android side is completely different than jailbreaking. Rooting gives you root access to the entire operating system. By virtue of having root access, you can remove the operating system, you can replace it, you can tweak it, you can overclock or underclock the processor, and you also get access to flash memory. Capacitive and resistive touchscreens. Resistive is the old style stuff. It was a lot harder to activate by touch. You really had to make a firm press on the screen in order to activate whatever key or button you were trying to hit. I had a dimmer display, and it's really older technology. Capacitive, that's what you're going to see on your iPhones and your Galaxies and all that. It's very easy to touch and interact with on your apps and things on the screen. It's got a lot brighter, crisper display. It works really well in sunlight, and that is definitely the newer technology. On virtualization, we're going to finish up here. Client-side virtualization, that is used on a network client to run multiple VMs, and actually it could be a standalone. VMs are virtual machines. In client-side virtualization, we're going to use a software app that could enable you to install and run multiple operating systems in their own separate virtual environments. Examples include VMware, VirtualBox, and Virtual PC. I personally started using VMware, so that's my personal favorite, but I'm sure everybody's got their own, just based on whichever one you started with. Those are hypervisor is used to manage that whole thing. Hypervisor, this is basically your hypervisor program here, your VMware, VirtualBox. There's two types of hypervisors though. If we're talking about a type 1 hypervisor, we're going to use Hyper-V from Microsoft. The difference between those two types of hypervisors, this is a great diagram to show that. Because down here, the hypervisor in a type 1 hypervisor, that's installed before any operating system is ever installed. It's called bare metal installation. So we're going to install our hypervisor. It's going to allow us to partition out the hard drive, and then within each partition we can install a separate operating system. On a type 2 hypervisor, we first these things get installed on top of the operating system. So for example, this VMware, that's a type 2 hypervisor, so it is a separate app that we're going to load in on top of Windows 7 or whatever OS you're using. So here would be our Windows 7, here's our VMware, and then within VMware we can create different virtual environments. I had a class I was taking a few years ago that I believe I had 3 different VMs. They were all running a different version of Windows Server. I think 2 of them were 2008, but then I had to interconnect those, and it's all running in a virtual environment. And that just virtual just means I'm rather than having a separate physical box, I'm running it in the software environment, but it thinks that it's got its own physical box. So that is it for video 4. I want to thank you very much for listening to all of this, and maybe we will see you soon.